All right, we are on video. For those of you listening at home, hi Rainey, and I think Josh for about an hour or so. Go ahead and look at that. He's coming. I do have the answer key for the practice exam, part 2. There are 1 or 2 omissions that the thing didn't print, so I don't quite know why, but I will put those on the board in a moment, no problem. And it's not the possibility that there might be a typo or 2. I'll see what happens. You might want to put the word key on this so you can distinguish. It is kind of visually obvious. Did I miss anybody? Or, oh, that's right. Did I miss anybody else? Answer key. Going once, going twice. Right. All right. So, look that over. The very first thing I want to do is fill in the 2 missing graphs for number 1. It did not print, it was supposed to be E and F, it's supposed to be positive tangent, negative tangent. So the positive tangent, the markers are slowly dying. The positive tangent should look like this. There should be 3 dots, low, middle, high, surrounded by asymptotes. Sort of a snake going uphill. That's a positive tangent graph. And then a negative tangent graph is very much like it, except the dots go downhill. So upper, middle, lower, surrounded by asymptotes, and this sort of snake goes downhill. Okay, everybody good? Yeah.
Did you get about answers?
I just did, yeah. Okay. Oh, you're just going back, sorry. Okay, so again, on number 1, 2 of the answers did not print on the answer key, so please copy these down. Everybody catch that? Yeah.
Also for the positive and negative sign, I graphed them like that, where you have the middle line. And so,
With positive, negative sign, you said?
yeah, instead of having them like off to the right side, I had them going across the middle line where 0 is.
Let me look.
Like that.
Okay, I'll let that go. Yeah. Usually, they want to cover 4 quarter periods, and that would be 2. Correct.
So on the exam, if we were to not put arrows like on the line, would that be canceled?
On the quick graphs?
Yeah.
I'm not going to be as picky on the quick graphs.
Okay.
On the actual graph, I would like you to do that, because the actual graph does go forever. Yeah, real fast.
And also, do you want us to write in like the pi over 2 to?
Oh, on the quick graphs. That was for your reference, and the answer again is no. But again, on the real graph, by all means, yes, that'll be like 80% of your grade on that one. So yes, Nate, question? Okay. Any questions on number 1? All right, so look over the answer key, see if there's anything that's missing, which is possible. There are, on number 3, there were, you can probably figure out what I meant, but on the positive sign and positive cosine, there were 2 options for starting points. So I put both of those in. Where it says, like for the top equation, it was 4 sine of pi over 14 x plus 3 plus 2. You can replace the x plus 3 with x minus 25 if you want. Because one of the horizontal shifts is -3, and the other one is positive 25. Okay. Ditto with the cosine. There were 2 options. One was 4 and one was 2. All right. I didn't leave a heck of a lot of space for 4, 5, 6, 7, and 8. There's a lot more space on yours. I just crunched it because I wanted to save trees. So you get the answers in there. Let me see. 9 through 12 is the tie problem. 13 was an extra credit tie problem, and 14 was a double angle extra credit. So, any questions on any of that? Any of those that got you stuck? Like your main thing we're going through today and tomorrow. Today is largely dedicated to part 2, although if we go completely through it, we can start dipping into part 1. I know part 1 is longer. is a catch-all. And, yeah, I wanted to ask you, would you find it helpful if I printed off a second edition of the practice exam and let you do it in groups tomorrow? Okay, I can do that. Let me make a note of myself so I don't spaz, which is perfectly in character with me. Practice exam part 2. Print. Yeah, and you've heard that my computer's dead, so I have to print everything at home and then bring it here and actually photocopy it like yeah.
Can you print it in one?
Oh, could I print this in one big lump?
That's just
Absolutely.
people.
Yeah, that's actually one of the easier things I've been asked. So yes, the final exam is going to be in one lump, so I have no problem putting the practice exam version 2 in one lump. Yeah, that would actually save staples. So thank you. So questions on part 2? Yeah.
Can you do number 7?
Number 7. Yeah, cosine of 285 degrees. Now, cosine of 285 is not a common angle. It's what we call a pseudo-common angle. But it's not common. It's not a multiple of 30. It's not a multiple of 45. You can check. 225 is a multiple, and 270, those are common. But the next common angle is 300 and 315. So this can only be gotten by a cosine addition formula. Can anybody think of two angles that are common that would add to 285? They can be big or small as long as they're common. Multiples of 30, multiples of 45, multiples of 90. You could also subtract, I suppose. I see. I see. Now, the fact that it ends in a 5 means that there's probably going to be a multiple of what in there? Yeah. 45, right. So if you have all multiples of 30, it's always going to end in a 0. If you have a multiple of 45, that might give you a 5 at the end. What's this minus 45? Yeah.
Did you 25 and 60?
225 and 60? As a matter of fact, you got, well, actually, let me see. Yes. That works beautifully. Now, the catch is, what is the, so this is A, and this is B. Can somebody give me the cosine addition formula? Cosine of A plus B. One other purpose of this day or two here is that I did promise that you can use a 3x5 note card, one side, on the exam, mainly for the purpose of these formulas. I'm not going to police what else you put on it. You can put anything you like on it. You can do, 2.5-point font and 5 billion things on it. Knock yourself out. I have done that once. I regretted it because there were like 500 itty-bitty little formulas, and when I'm stressing out in the middle of exam, it's really, really hard to find the needle in the haystack. Just saying, yeah.
I'm sorry if you already said this, but is it on the front and back or
Just one side. Yeah. Yeah. Kind of what? As long as it, oh, I see. So you're gonna print 2.5-point font? As long as if it's not a 3x5 note card, bring it to me so that I can measure it. If it is bigger than 3.5, I have a scissors. And I might not be discriminate as to what I cut. So it is in your best interest to measure it ahead of time. Okay, so we've got cosine addition formula. Go.
What was the question again?
What was the cosine addition formula?
Cosine of A plus or minus B equals
Cosine of A plus or minus B equals,
cosine of A cosine of B
okay,
minus plus
minus plus, good.
sine of A sine of B.
Sine of A, sine of B, good. Now in this particular, what is minus plus 1?
So if
Like if I do addition in the first place, what would I do?
Subtraction.
Subtraction in the other. Go ahead and do that. Match up the A and the B and the minus sign where it's appropriate.
Cosine of 225,
Yep. Actually, now you should say
cosine of 60,
cosine of 60
and minus
minus,
sine of 225, sine of 60.
Does that make sense? It doesn't really matter what two angles you do as long as they add up to 285. There are other ones that work. There are, you could do 330 minus 45 off the top of my head. You could do 135 plus 150. There are several options you could do. As long as the two of them add or subtract to make 285, and as long as the two angles are common, you can do this. Now, the second and last catch is, can you find these values in your head or on paper? These are the ones that we drilled on the unit circle. Cosine of 225, start at the beginning. It's going to be something times something minus something times something. I actually do that whenever I do a test. Whenever I have a formula, I put blank parentheses, blah, 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 so that I don't miss anything, and so that if I plug in a negative and I happen to square it or something, I don't forget to do that. So, can somebody tell me cosine of 225? Yeah.
Negative radical 32.
Yeah, cosine of 225, that's over here. Cosine is left, right, so this is to the left. And any multiple of 45, the sine and cosine are radical 2 over 2. That's the only fraction. So this is going to be negative radical 2 over 2. Again, it's to your benefit to have those fractions memorized. Cosine of 60, Nick. Here's 60. 1/2, positive or negative? Positive. Cosine is left, right, and 60 degrees is to the right. It's a multiple of 30, so it's either, I would ask, is it to the right a little or a lot? 6 degrees is over a little. That's 1/2. The big one would be radical 3 over 2. All right? Sine of 225. Right, Clark? Good. It's down, and it's that fraction for multiples of 45 again. Negative radical 2 over 2. And the sine of 60, hey. I'm sorry? Radical 3 over 2, correct. Can somebody simplify this for me? Megan, help me out here. Multiply these for me. Good. And then what's this going to be? What? Go ahead. Radical 6 over 4. And then just combine them. By the way, it really doesn't matter what order they're in. I like the radical 6 in front, but it's totally up to you. So what would you write? Minus radical 2 over 4. Correct. There you go. Yeah.
So in our notes, you did plus minus radical 6 and then plus minus radical 2. Could you
Could you do it that way?
do it in your head instead of doing all that?
Yes. The short answer is, could you avoid the addition formula if you have the pattern memorized? Short answer is yes, you can. This is called a pseudo-common, which is a non-common multiple of 15. There are 8 possible places on the unit circle that have pseudo-common angles. 285 is right here. And if you're talking about cosine, now, any pseudo-common is going to be plus or minus radical 6, plus minus radical 2 over 4. You choose the positives or negatives that be appropriate. Look at cosine. You notice it's cosine over a little or over a lot. So it's like a little positive, a lot positive. A little negative, a lot negative. Does that kind of make sense visually? So which one would be over a little? So in other words, cosine is to the right. But in this case, it's over to the right a little. So it's just a little bit positive. what combination of plus and minus would make the answer on top positive, but only a little bit positive?
Plus radical 6 minus radical 2.
Plus radical 6 and minus radical 2. So they're fighting each other. Radical 6 is pretty big, but if you subtract radical 2, it drops a little bit. Does that make sense? It goes smaller. And that's exactly what we have over here. If you had radical 6 plus radical 2, they would join forces and make even bigger. And that would be a big cosine positive. Okay? If you wanted to go a little bit negative, you would make this negative and this positive. So they'll still fight each other, but the answer is a little bit negative. If you wanted to go way negative, make them both negative and they join forces. Does that make sense? Again, do you have to do this memorized pattern? No, you do not. It is a potential fast shortcut. But if you get stuck in there, just do the angle addition formula. Next. Yeah,
Can I just go back and put one on?
go ahead. Any others have you scratching your head? How'd number 8 go? Did we go? Yeah, go
I
ahead.
was just gonna ask if you do it.
Number 8, okay. Sure, why not? And all 5 of these markers are next to dead, so grab my reserve marker. I am, a little disappointed I have these itty bitty little pathetic markers. And I have like, I have a purple marker, which I just don't want to do that unless like my life depends on it. And I have these like off-brand yucky blue markers, so I'm gonna try the off-brand yucky just to see what happens. I'm probably gonna regret this. I think even a half-dead expo might be better than the yucky markers, but we'll see. Number 8. Yeah, see, it's getting harder and harder to erase this. I gotta press harder and harder to make the dying markers work. That sounds cruel. They're dying, you better push them harder so that they can work. That really seems, oh, this is awful. No, this is a teeny little wedge. No, this is like their calligraphy. Lame. Ditto, ditto, ditto. Come on, is that, am I gonna have to use purple? For the first time in I don't know how many years, purple marker. All right, so we've got, what was, I forgot the question, what was it? Oh, cosine of x, wow. This is just, Randy, if you're trying to adjust the color of your monitor at home, no, it actually is purple. You. Cosine of x minus sine of x. I don't have a war against purple or anything, but it's just, I'm so used to blue. This is kind of traumatizing. And then cosine of x plus sine of x. All over 2, what was it? 2 sine of x, cosine of x. And I apologize for the computer not putting it in a fraction form like this. It just didn't fit. So, sorry. The top, you can foil. If you foil this, it becomes cosine squared of x plus sine cosine minus sine cosine minus sine squared. The two middle terms cancel. And then the bottom just doesn't do anything. It's just 2 sine of x cosine of x. This color's really doing funny things to my brain. It's like I keep doing it. It's been too many years. So it's cosine squared minus sine squared over 2 sine of x cosine of x. Now again, has anybody ever seen cosine squared minus sine squared before? Yeah.
Isn't it tangent?
Cosine over, well, sine over cosine is tangent.
Oh, over.
It is in that list of formulas though. Somewhere. Yeah.
Isn't that cosine of 2a?
That's cosine of 2a, or in this case, 2x. That's a double angle formula for cosine. It's cosine squared minus sine squared. Does everybody recognize the bottom? Yeah.
Sine of 2x.
That's the double angle formula for sine. That's the sine of 2x. And there's one last thing you can do to reduce that. What's sine over cosine? Back up. Tangent. So what's cosine over sine? Cotangent. Cotangent of what in this case? Yeah. Cotangent of 2x. Did you find that? That make sense? Okay. So the formula, just to refresh your memory, the sort of exotic formulas we went through, and if these are particularly sticky, these might be what you want to focus on your 3x5 note card. There is the sine angle addition, cosine angle addition, or subtraction, tangent angle addition. Then we had the sine, cosine, tangent double angle formulas, and then the sine, cosine, tangent half angle formulas. Those are all fair game. So if you don't think you have them off the top of your head, squeeze them into your note card somewhere. Okay. Next. Any other ones you want to see dissected or thrashed out? Yeah. Number 9. Sure, why not? I was actually half expecting that one. Alrighty. I wanna write something. Let's just see if I can erase it. Does purple erase well? Yeah. I'll deal. Y'all are worth it. The day Mr. Kaplan took a purple marker, and he did it just for us. So, you're a scientist measuring tides at Pebble Beach. You start your measurements at midnight on August 3rd, 2022, the next year's day. You know that on August 3rd, 2022, the first low tide was 3:48 a.m. in blah, 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 blah. The very first thing I would do, set up a tide graph. A tide graph will not have anything negative to the left, and it usually won't have anything negative height-wise, because usually you don't get negative heights for tide. Sometimes you do, like the Dead Sea, but I don't know if the tides have to worry about that. But sometimes they do. Now, the two things we can immediately mark are the heights of the low tide and the high tide. I would do that first. Don't worry about the times just yet. The low tide is 2.98 feet. I would just mark that immediately. 2.88 feet. And then the high tide is 6.26 feet. You tell me what to do next. Well, next people. Go.
You can find the dates.
How?
So you add the two together and then divide by 2.
Correct. You take the average of the top and bottom. So it'll be 6.26 plus 2.98 divided by 2. What do you actually get on that one? 4.62, correct. Feet. What do you do with that? Courtney, tell me something else we can find, just based on what's on the screen. Board. I'm such a tech geek.
You can find
The amplitude, how?
subtract the base from the next one.
Yeah, or base minimum, whichever you like. Go ahead and do it. What do you get? 6.26.
1.654.
I'm sorry?
1.64.
1.64, sounds good. 1.64 feet, basically. So the amplitude is 1.64. The baseline is 4.62, and those are two of the 4 things we need in order to make our graph. Now, time to play with the times of day. No pun intended. Okay, next slide. Righty. Sam. First low tide, 3:48 a.m. I'll mark it in human terms. How do you convert that to computer terms, so to speak?
You do 48 divided by 60,
Right.
and it's 3.8.
Yeah, 3 plus 48 out of 60. You just want the total number of hours since midnight on, what's it, April 3rd? Yeah, August 3rd. You do have to keep track of the day. August 3rd, 2022. Because one of the problems is probably gonna ask for the tide on a different day. So you may have to figure out where you're counting from and how many hours has it been. So 348 is and it's correct, this reduces to 3.8. And was that a high tide or a low tide? Low tide. You put a dot right here. That, by the way, is one of your answers for number 10. It's 3.8, comma, 2.98. And you would call that a negative cosine start. Okay. What else happened in this whole mess? Spencer? We got low tide. When did the high tide happen, according to the data? 1:12 p.m. What day? What's that? Yeah, same day, August 30th. So 1:12, you said? Okay. So in human terms, 1:12 p.m. Put that in computer terms. Tell me how. Yeah, add 12 because of the p.m. Then a 1 for the afternoon. 12 over 60. What does that reduce to? Point. And 12 over 60 is what? So 1 over 5. What's that as a decimal? I'll give you a sneaky hint. 1 over 5 is the same as 2 over 10. Also known as 2/10. 0.2, exactly. By the way, that was totally lucky, because if it has something in common with 10, it's nice. So okay, 13.2. Was that a high tide or a low tide? High tide. So the other problem on number, whatever that was, number 10, was a positive cosine start at 13.2, comma 6.26. Those are the two easiest start points to use, and I would recommend you use those. If you're feeling just absolutely bored in the middle of an exam, which doesn't happen very often, you can find the positive sign start, you can find the negative sign start, whichever you like. Do it at your own risk. If you get the wrong answer because you divided wrongly or something like that, oops. We do know that it curves up like this. So if you absolutely wanted to do this, it's halfway in between these. So it's not that horrible to get. And then you can get a quarter period based on that. But really all we need is one more thing. How long is this? Blaze, help me out here. How do you find that?
You subtract 3.8 from 13.2.
Yeah, what do you get?
9.4.
9.4. Is that a full period?
No,
No, it's what?
half period.
Half a period. So 1/2 period, I write it like that, equals 9.4. What would a whole period be?
Would be 9.4 times 2 is be
Yeah, 9.4 times 2, which is
18.8.
18.8. Everybody clear on that? Now, we've got the period, we've got the baseline, we've got the amplitude, and depending on which point you start from, we have the horizontal shift. Can somebody give me, actually, somebody pick, tell you what, Katie, help me out. Pick positive or negative cosine, whichever your favorite is. Negative cosine? Okay. So can you give me a negative cosine equation based on this stuff? Y equals what? Otherwise, don't forget y equals, otherwise I'll take out points. Go ahead. And it's a negative cosine. Yep, negative 1.64 cosine. And then what do I put here? This is A, B, H, K. What do you put for B? It's going to be a fraction. So that kind of, sort of. That is true. What's the unreduced version? 2 2 pi over p, which in this case is 2 pi over 18.8. You're perfectly welcome to do pi over 9.4. That's fine. Just don't try not to do any arithmetic mistakes when you do that. And then parentheses what? Keep going. 3.8, right. If you're starting at a negative cosine, that's how far over it is, 3.8. Don't put 3.48 by mistake. That's not a decimal, that's a time of day. And then pren plus what? That's the min. 4.62, nice. Everybody clear on that? That should be the answer for problem number 11. Or not number 11. I didn't even ask you for the equation. Will you? I'm gonna do this. No, I'll just keep it as is. Now you're gonna need it, obviously. Otherwise, you're not gonna use your psychic powers to answer number 11. I think it's 3.1688 feet for some strange. No, maybe there's some guy in India that can do that instead, but I can't. So, and unless you have powers beyond the lot of mortals, I don't think you can either. So yeah, get the equation. Righty. Number 11. How do you do that one? It says to the nearest 10,000, predict the height of the tide at 3:57 p.m. on August 4th. Note, different day. Come ahead and do that. Nate, come in.
High tide is 6.26, so you just find the high tide that's on that day.
That's number 12. Number 11.
Oh, the answer?
Yeah.
3.1688.
How do you get it? Plug what into the calculator?
That equation.
You're on the right track, but there's a lot more you have to do. So, start at the beginning.
So you have to find where 357 is.
Yes. In other words, I need to find August 4th, 2022. You know, thank God it's the same year. 3:57 p.m. Translate that into hours for me. Talk me through it. Now, the beginning was midnight, August 3rd.
So you had 24.
Yeah, 24 hours because it's a new day. Plus,
15.
yeah, plus 12 plus 3. Let me see where the 15 came from. 12 because it's PM, and then 3 hours, and then keep going. 57 over 60. What does that reduce to? Yeah, this is 0.95. By the way, it's utterly lucky. 24, 30, 36, 39. So the value of x you're going to plug in is 39.95. Does that make sense? Where do you plug it in? Chetler?
You put it in for X.
You put it in for x in this big choke horse formula. Okay? So on your calculator, you would put negative 1.64 cosine, parentheses, 2 pi over 18.8, new parentheses, 39.95 minus 3.8, paren, plus 4.62. And God willing, you should get 3.1688. If you don't, let me know, because something just went wrong. Yeah?
So does it matter if you use negative cosine
Does it matter if you use negative cosine or not? It kind of depends. If you had done positive cosine, the formula would be very similar, but it would be this. Y equals positive 1.64. What am I doing? 1.64. That is horrible, 1.64. I'm trying to avoid this gash on this board here. Cosine, this is the same, 2 pi over 18.8. This will be different. X minus 13.2. Paren plus 4.62. If you plug in 39.95 into this or into this, you should get identical answers. Should, in any of the 4 forms, positive sign, negative sign, as long as you have the correct data, you should get identical answers on all 4 of them. So it's relatively forgiving. All right. Any other ones you want to go through? We have about 10 minutes, so. Just out of curiosity, did anybody try number 13? I am going to have an extra credit problem like that. Do you see how I did it? So in 2022, if you finish out 2022, you add up the days for the rest of the year. Then if you've got entire years, it's easier. Just remember 2024 is a leap year. And then 2025 is not a leap year. And then there's 2023. Then blah, 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 blah. That's the hours, then 12 extra hours, yada, yada, yada. Okay? Then move on to scene number 14. No, Mr. Kaufman. It's traumatizing. Now, by the way, I want to give priority to the other ones. Are there any other problems on the regular part of the test? Yeah.
No, I have a question for this one.
Ah.
Is the calculator supposed to be readings or degrees?
Excellent question. Muy bien. If you are doing trig on the earlier part of the test, which you probably will, you're probably having it in degree mode, because they're saying find the, like if you're trying to find the height of a tree or something. Did I even put a problem like that on the test? I'm just batting 1,000 on this test. No, I'm sticking to what I gave you on the practice test. Fair is fair. I'm not going to surprise you. But make sure that when you have a graph, here's the thing that'll tip you off. See the 2 pi up here? That's radians. So make sure it's in radians. Yeah, if it's in degrees, you're going to get, that's the funny thing. People think, well, if it's in degrees, I'll just get this insane answer. No, you won't. You'll get an answer between 2.98 and 6.26. It'll just be wrong. And there's very, very little chance of knowing that it's wrong, unless you happen to know exactly what the graph looks like. Yeah, quick question.
So for calculating like the height of the tide, when you go to the equation, could you technically find your calculator for 2 pi over 18.8? Could you just multiply pi by 2 and then all divided by 18.8 and then plug the decimal number for the equation?
Maybe say that again. The numbers.
So like, if I multiply pi by 2 and then divided it by 18.8.
And then get some sort of weird decimal.
Yeah, and that just plugs it into the equation.
Yes. It's a little, if you have a display calculator like the TI calculators I have here, it's much safer to put pi in. Partially because if you multiply pi by 2 and then divide by 18.8, it's going to round off a little bit. And then technically the only time you're ever supposed to round off is at the very end of the problem. If you round off, then use it, then round off, then use it, then round off, your answer could be pretty crummy by the time you're done. So if you can use pi, use it. Otherwise, use every single digit it gives you. Don't round off to the nearest tenth or something. Yeah.
I'm not getting the right answer.
Ah, okay.
I got 3.1923. And I don't know what I'm doing wrong. I've typed it in like 5 times.
Hang on a second. Well, at that point, let me double check and make sure mine is right. It has been known to be a little wacky.
No, it's in, yeah, it's in radians.
Radians, okay. Oh, mine was in degrees. Let me try this. So we've got, I'm going to do the negative. Which one did you do, positive or negative?
I did negative.
Negative, okay, I did too. So negative 1.62. 4. That was a close call. Negative 1.64 cosine, then 2 pi over 18.8. New parentheses. I'm going to type 39.95 minus 3.8. Close parentheses, plus 4.62. Then I got 3.16883. Let me take a look. Well, go ahead and type it in. Did anybody else get a number that wasn't friendly? Okay. Yeah, call me over. I can probably spot.
No, I got 3.1488.
Hold on.
I don't know what I'm doing.
I get that. Close. Okay.
Like mine.
Yeah.
It happened like 3 times while I was trying to type it in.
And then it.
162.
There.
Nice. Okay.
Oh my gosh.
Very good. Were you doing positive or negative? Oh, negative cosine would be 3.8. Now's the time to chase these down. Believe me, I'm just speaking from my own experience. I don't know if you've had this experience where, like, wow, this is like 1/4 of the test, tide problem, clickety clickety click, and then you get an answer that's just, you get an error or something like that. The first reaction is, especially if this is the first serious problem you've hit on the test, it's like, yeah, sketch for positive signs. Yeah, positive sign star. Shh, done. But as soon as you get one of these and you say, error domain or something like that, you grab a paper bag and you start breathing into it because you're going to be hyperventilating. Now, first of all, don't panic. There's usually a logical explanation. And by the way, this is an important point. Pun slightly intended because it can save you points. Show your work to the extent it's possible. Let me show you what I mean. If you look up here, this could save you a lot of points. Show me this. You notice I never showed you, I never asked for the equation. Write it anyway. How come? If you give me a number out of the clear blue sky for number 11, and it's wrong, and the only thing you wrote in the number 11 slot is the wrong number, I will have absolutely no idea. I will start, just because I'm a nice guy, I will start looking through the entire page saying, is there anything that could possibly have yielded this? I'm looking for an equation. And I look and I look and I look, and if there's absolutely no equation, that means you probably, the only place you put it was in your calculator. I can't grade your calculator. So please write this. And by the way, if you want to show even more work, write this. Well, I didn't think it was. Let's just say, here's what I would do if I wanted to get the maximum amount of partial credit for a wrong answer. Y equals -1.64 cosine, parentheses, 2 pi divided by 18.8, new parentheses, 39.95 minus 3.8, darn it, plus 4.62. If I write that, and then I write y is approximately, and then I have some sort of goofy, like 1.2345 or something like that. Yeah, I mean, my first reaction when I'm grading this is, what the heck was that? But if you have this, I know you know how to do the problem correctly. I will give you most of the credit if I see that. Because this shows, they understand tide problems. They've got the A, B, H, K, they're all correct. And the only reason there's a number wrong, typo. I do not take off much for typos. I think at most I would take off like 3 out of 10. If you showed me this much work, I know you know what you're doing. And anybody can do a typo. Or put a parentheses in the wrong spot, or something like that. By the way, if I see on your written version that there's a parentheses in the wrong spot, that might be helpful too. I will try and recreate what you did, and if there's a parentheses in the wrong spot, and I get the exact same answer you did, I said, Eureka! Elementary, my dear Watson, I've just found out what the problem was. And basically, if I find out if it's just a typo or you're writing, a righto, and it's nothing major, I will not take off major points. Clear? So it's in your best interest to show your work, even if they don't specifically ask for it. The more work you show, the greater chance I'll give you more points. Now, if the work makes no sense and the number makes no sense, there's not much I can do for you. But I don't think anybody's in that boat. So, tomorrow, do me a favor. Your homework assignment for tonight, quote unquote, is to go through part 1 and part 2 of the exam, practice exam. Get a list of questions you want to go over. I will also have the version 2 for you that you can work on in groups if you like, but I will be here to go through anything and everything you want. Make sense? Please stand. Let us pray. Turning in your books. Yes, I'll do that tomorrow. So yes, please do. If your book is gathering dust somewhere, please dust it off and bring it. Yeah, I'll send an email reminder as well. Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and the Son, and of the Holy Spirit. Right? We all have. Thank you. The computer. Oh, yes, thank you.